Okay, so let's start. Okay, we're going to do coordinate geometry. So I think someone requests for coordinate geometry asking about line segment. Line segment means is okay, let me just talk about some formula before I start off. So someone asked about line segment. Okay, so it means like, for example, this is a straight line. And let's say I have a coordinate. Let's say this one is 1, -3, and let's say this one is 4 and 7. Okay, so the coordinates of these 2 points is 1, -3 and 4, 7. So line segment, okay, you have 2 information. You can find the gradient of the line. Okay, you also can find the length of the line. So if I want to find gradient of the line, we will use m is equals to y1 minus y2 over x1 minus x2. Okay, so y1 minus y2 means I will take, you can either decide this one is your y1 or this one to be your y1, doesn't matter. Say let's say I start from my y1, which is here 7, so I will say 7 minus my y2. Take note that you see your y2 is negative, so it's subtract -3. Then x1, because I let 7 be y1, so 4 has to be x1. So 4 minus 1. So 4 minus 1. So you will get 10 over 3. So this is the gradient. So you can write, usually we'll put it in mixed numbers, so it's 3 1/3. Okay, so this is the gradient. So you see, gradient is positive. Okay, which is correct because your line is slope up. The line is slope up. Okay, next is you want to find the length of this line segment. The length of this line segment. So I will use the, actually the formula actually comes from Pythagoras Theorem. So if I'm going to dot, okay? So you look at here, from here to here, what is the length? It's the y coordinate. You take 7 minus -3, so we know it's 10 units. So here is actually 10 units. From here to here, from 1 to 4, it is 3. So this part is 3 units. So actually to find the length, is actually finding the hypotenuse. So it's actually just 3 units square plus 9 units square, then it's whole thing square root. So actually the formula comes from Pythagoras Theorem. So the length, we will put square root. So it will be x1 minus x2 square plus y1 minus y2 square. Okay, you want to write x2 minus x1 square plus y2 minus y1 square also can. It doesn't matter. Because after you square it, it's still the same number. Okay, so my x1. So just now I let this be my x1 and y1, right? So 4 minus 1. So 4 minus 1 square plus 7 minus -3. So 7 minus -3 square and square root. Okay, so 4 minus 1 is 3. This one is 3 square, so it's 9. 10 square, so this is 100 square root. So square root 109 will give us 10.440. So round it off to 3SF, you will get 10.4. Okay, for coordinate geometry, there's no cm or meter. You will say this is units. Okay, so this is the length of a line segment. Okay, so this will be this part. Okay, let's start some questions. Okay. No, today is EMath. Okay, today is EMath coordinate geometry. It's not AMath coordinate geometry. If you want AMath coordinate geometry, you can go and look at the 2 modules that I give for free access. One AMath is coordinate geometry. EMath is, what's EMath topic? Oh no, I forgot what. I suddenly forget what's the EMath topic I give you. Never mind, doesn't matter. Okay. Anyway, AMath coordinate geometry is given as free topic. Okay, you can go and access from there. Okay. Hi. Okay, so let's start with this question. The diagram shows a triangle PQR with coordinate. Every time when you read the question, make sure you also refer to the diagram and make sure that all the information are transferred to the diagram. Okay. -8, 0. Okay, just all is here. So acknowledge. 10, 0, acknowledge. -5, 9, also acknowledge. they say that the line QR cuts the y-axis at point S. So this is point S. Okay, this is point S. That's all. That's all the information they give us. Next is, they say find the length of QR. Okay, QR. So QR is from here to here. And because remember, I have my two coordinates, right? So just now I already teach you how to use the length formula, right? So you will say length of QR will be equals to square root x1 minus x2. So I take minus 5 minus 10 square plus 9 minus 0 square. Okay, and we will get 17.4928. So round it off to 3SF, you will get 17.5. Okay, and the units is units. So put here, this is 3SF. So this is just finding the length QR. Okay, next part. They ask to find the equation of the line QR. So whenever it's a straight line, okay, you must know that the equation of a straight line is y equals to mx plus c. Okay, that's the first thing you write. Then you will find the gradient first. So I'm going to find the gradient QR. So gradient QR, so we will use back the two coordinate as well. So our gradient formula is y1 minus y2 over x1 minus x2. So I will take 9 minus 0. Okay, y1 minus y2 over x1 minus x2. I will write as 9 minus 0 over minus 5 minus 10. And we will get minus 3 over 5. So this is the gradient of the line. So my equation of a straight line is y equals to mx plus c. So since you find the gradient already, you can replace the m with the gradient. So now my equation of the line is y equals to minus 3 over 5x plus c. Now the next thing is you need to find c. So to find c, you just need to sub any point which is on the line, any point. So in this line QR, I have 2 points. So you want to sub in minus 5 and 9 also can. You want to sub in 10, 0 also can. Okay, then what you need to do is, okay, I'm going to write here. So we just say, okay, I'm going to sub in 10, 0. Okay, you can choose. Usually I don't like to sub in negative if I have a choice. Because sometimes when we deal with negative, it's very high chance of careless mistake. So sub 10, 0, we will have 0 equals to minus 3 over 5, 10 plus c. So our 0 equals to minus 6 plus c, and therefore c is equals to 6. Therefore, equation of the line is y equals to minus 3 over 5x plus 6, and we are done. So this is to find equation of a straight line. Okay, always remember the steps, very straightforward. First, y equals to mx plus c. Next, find the gradient. And of course, you have to memorize the formula to find gradient, which is, they call it rise over run, but it's easier for you to remember y1 minus y2 over x1 minus x2. Then after that, fill in the m. You're still left with one unknown c. Just sub in any point which is on the line. So for I choose to sub in 10, 0. Sub in, it becomes a linear equation solving c. And then you have a c now, and then you have the complete equation of the line. Okay? Okay, next. You see, they ask you to find coordinate s. Coordinate s. So where is coordinate s? Just now the coordinate s, we know that it's stated that it's cut the y-axis, correct? Actually, I don't have to do any working. Why? Because this is only 1 mark. This is only 1 mark. Okay, this is set 3 coordinate geometry. Okay, so you look at this. Y equals to minus 3/5 x plus 6, correct? This plus 6, okay, I'm going to write here. Okay, I'm going to write this behind here. So y equals to minus 3/5 x plus 6. Okay? You need to know that this is gradient. This one is gradient. Minus 3 over 5, this is gradient. Okay? This is y-intercept. Y-intercept means where it cuts the. This is EMath coordinate geometry. Can you see? Actually, I already write the title at my side here. I wrote EMath coordinate geometry and further trigo. right? It's right below me, I wrote there, right? EMath, coordinate geometry, and further trigo. Okay, so then after that, y equals to minus 3/5 x plus 6. Okay, let's proceed. So that means I know my y-intercept is 6. So therefore, straight away you will know my s is 0, 6. You don't have to do any working because we already know y-intercept is 6. That's why it's only 1 mark. Okay? Okay, let's move on. The area of quadrilateral OPRS. Okay? Let's take a look at the diagram. Okay? OPRS. So in other words, they want you to find this. Let me take my highlighter and highlight the shape. Lama. Where's my highlighter? Okay, I cannot find my highlighter. Okay, never mind. Okay, anyway, this is the shape they want. Okay? So I can label here, this is 0, 6, which we already found it. Okay? Now, this is EMath coordinate geometry. I understand that for those who learn A-math, you can use the shoelace method to find the area, correct? But take note, this is EMath. So EMath means you have to always find half times base times height. That means find triangle. This is a quadrilateral. I'm going to cut it into 2 triangles. Okay? So what I'm going to do is draw dotted line. I will cut into this shape, these 2 triangles. Okay, so I will find the area of the first triangle and the second triangle, add them together, and that will give us our area of the quadrilateral. Okay? Okay, let's see. So over here, let's take a look. So my area of the triangle, this part. Let's take a look at the first triangle over here. OPR. Okay? Yeah, if you are EMath, you have to use half times base, find 2 triangle. You cannot use shoelace method. Okay, you cannot use shoelace method because this is EMath, not A-math. So let's analyze this. Okay, let's analyze this. This triangle, the base, big triangle minus, why not area of big triangle minus small triangle? May I understand where is your big triangle? Oh, this triangle minus this triangle, is it? Okay, let me see. This one minus this. No, this one minus this. Also can. Okay? Han Quan Pun, is it? Okay. What Han Quan Pun means is why cannot use big triangle minus small triangle? Also can. It depends on whether you have the base and the height. So what he means is he want to use this triangle, this big triangle minus this triangle. So then you have to ask yourself, do you have the base and height in order to find that? Yes, we do have. Because this is the base and this is the corresponding height. Correct? This is the base and this is the height. So that also can be done. Okay? For me is I cut these 2 triangles. Okay? So because I also can find this is the base. See here, from here to here, I will know from minus 8 to 0, this is 8 units. Yes. And then you will so-called draw the height. And this height, look at the y coordinate, is 9. So this is 9 units. So the first triangle POR is half times 8 times 9. Okay? Then I'm left with this triangle RSO. So I will have to turn the diagram a bit so that you can visualize. So now let's focus on just this triangle over here. Okay? So this is my base, which is 6 units. And where is the height? The height is here. And what is the height? It is the negative 5 to 0, right? So this is 5 units. So I can find half times 6 times 5, which is a small triangle, plus just now that triangle, and that will give you the same thing. Yes, it's the same. You will still get the same information. You will still get the same answer. Okay, so I'm going to write over here, I will write area of triangle POR POR, you will write it as half times 8 unit times 9 unit. That will give you 36 units square. Area of triangle RSO will be half multiplied by 6 unit multiplied by 5 unit, 15 units square. So therefore you will know that area of OPRS will be 36 plus 15, and that will give us 51 units square. Done. Okay. So this is how you use area of triangle, cut them into basic shape, in this case is triangle, and then add them together. Okay, so just now another student suggests big triangle minus small triangle also can be done. Just make sure that when you choose that method, you are able to have the base and the height in order to find the triangle. Okay, so take note, EMath, you cannot use shoelace method. Okay, that's for question 1. Now let's move on to question 2. Question 2. So now this question, commonly asked. Okay, and then student always stuck. A straight line, actually it's pretty straightforward. If you understand just now what I mentioned about the y equals to mx plus c, always remember straight line y equals mx plus c, y equals mx plus c, y equals mx plus c. You will know what it means. So over here, a straight line is equation 3y minus 2x plus 5. So now this is not y equals to mx plus c yet, but it's okay. You can change the subject and make y the subject first. So 3y minus 2x equals to 5. So my objective is to make y the subject first. So 3y equals to 2x plus 5. Divide by 3. I have y equals to 2/3 x plus 5 over 3. So over here you can see that my gradient is 2/3. So you know that gradient is 2/3. Okay, y-intercept is 5 over 3. Right? And when they say, now you need to find the equation of another line which is parallel to this first line and it passed through this negative 1, 4. So it's something to tell you that, oh, this is a line this way, okay, which is y equals to 2/3 x plus 5 over 3. They ask you to find another line which is parallel, okay, this second line, question mark, and they tell you this second line pass through this point minus 1, 4. So maybe say minus 1, 4 is your example. So your task is to find equation of this second line. So when they say lines are parallel, it means the gradient is the same. Gradient is the same. So I know that my equation of the line, the second line, will be y equals to 2/3 x plus c, because the gradient is the same. So it will be, remember, y equals mx plus c, so I will say it's y equals to 2/3 x plus c. Then remember just now I teach you how to find c. You need to start any point which is on the line, and they give us 1 point. So it means that I will start in negative 1, 4. So 4 is the y, so it will be 4 equals to 2/3 negative 1 plus c. So it means that c is equals to 4 plus 2/3, and we will get 14 over 3. So c is found. So now is equation of the line. So it's just, y equals to 2/3 x plus 14 over 3, and that's your answer. Okay, this 3 will be ugly. Let me rewrite. Okay, so that is how you find equation of another line parallel. So gradient is the same. So the first thing you need to do is shift until you make y the subject. Then you know what is the gradient. Understand? Then form another equation of the line which is y equals to 2/3 x plus c, because it's the same gradient. Parallel line gradient is the same. Only the c is different. So I need to start a point which is on the line. And that's where I start in my negative 1 and 4. Start in, and then it becomes a linear equation solving c. You solve the c, and that is your complete equation of the second line. Okay, next. They say, okay, now they tell you the distance between 2 points. One point is called K2 and one point is called 1, 0. They are saying the distance between 2 points. Distance between 2 points is the same thing as the length of the line segment. Okay? they tell you these 2 points, the length is this. So simple, we're going to use the equation and the formula that. Thanks. So remember just now I teach you to find the length. So that's okay, we're going to find this. Don't worry about the k, because you're supposed to form equation solving k. So we will say, okay, k minus 1, 0 plus 2 minus 0 square. This is the length, which they tell us is equals to square root 2k plus 2. And when both sides have square root, means that you can remove the square root. Okay, and you will have, this one will be k square minus 2k plus 1. This is 2 square, so it's plus 4, equals to 2k plus 2. And you know that this is a quadratic equation. If it's a linear equation, k on the left, number to the right. This is a quadratic because it's k squared. So I will throw everything to the left hand side and make right hand side 0. So it will be k squared minus 2k plus 5 minus 2k minus 2 equals to 0. Then it becomes k squared minus 4k plus 3 equals to 0. So this will have to solve by factorization. So we're going to do our cross method. K squared plus 3 minus 4k. K, 3 and 1, because this is minus, minus, minus. Minus 3k minus, minus k and minus 3k. This side is add. So this is correct, and this is correct. So in the end, I get k minus 3, k minus 1 equals to 0. K minus 3 equals to 0. So k equals to 3. Or k minus 1 equals to 0. K equals to 1. Done. This is how is it? So don't have to worry. A lot of time you just need to just use the same standard formula. You just fill it in first, then you will see, oh, it's just forming an equation solving k. And that's all. Okay, let's move on. Okay, that will be question 3. Okay. Okay, let's read the question together and make sure that all information are transferred to the diagram. So in the diagram, the AB, the line AB meets the y-axis at 0, 6. Okay, so just with the 6, I don't like. I like to write the full coordinate. So at the side here, I will write this as 0, 6. And the x-axis at 8, 0, which is here. Same thing, they did not write the full coordinate. So I'm going to just write here 8, 0. Okay? The coordinate of the origin will be 0, 0. And they tell us that OD is perpendicular to AD. OD is perpendicular to AD. So to remind yourself about this perpendicular characteristic, we put a 90 degree there to remind us that it's perpendicular. Then they tell us that point C lies on the x-axis, which is here. Okay, they did not mark out the C. It's okay. You can just mark out a point C here. Okay, and then just state C, 0. Why I write C, 0 is because no problem. Okay, I know the y coordinate is 0. The only x coordinate, I mean the point that the information that I don't have is the x coordinate. So I let it be C. Okay, I usually don't like to let it be x, because it's very confusing. So I will use other alphabet except x and y. So I let it be C. So now, find the equation of the line AB. I believe by now you should be an expert to find the equation of the line AB, correct? So now tell me, what is the first thing I have to write here to find equation of a straight line? What's the first thing I have to do? Okay, what is the first thing that I have to write? What's the equation? Well done. Y equals to mx plus c. That's always the first thing you write because it's a straight line. Next, you need to find your unknown m, unknown c. But it is always in this sequence whereby you need to find your m first, which is the gradient. So to find the gradient AB is very easy as long as, yes, well done. Okay, as long as you have 2 points which is on the line. So let's take a look at the AB. I have 0, 6. I have 8, 0. That's why I like to write out the full coordinate. If I only see 6 and 8, I might not be able to link it, you see. So remember, it will be y1 minus y2 over x1 minus x2. So I have 6 divided by negative 8 minus 3/4. So now I have my y equals to minus 3/4 x plus c. And now, can someone tell me how do I find my c? How do I find my c? In this case, actually I don't need to find my c because I already know what is my c. Okay? Can someone tell me how am I going to find my c? Dang, dang, dang. How do I find my c? You are supposed to find this line AB. So I already find the gradient. So now is I want to find my c. And my c is the y-intercept. So how do I find my c? Anyone? Okay. Yes, sub 1 of the point is correct. You definitely no issue. You want to sub 0, 6 or sub 8, 0, you will still get a C. But remember, C is the y-intercept. This line, I already know where it cuts the y-axis, which is 6. So it means that I can straight away know that my C is 6. So I can write additional here. Since line cuts y-axis at 6, therefore C is equals to 6. Therefore, equation of the line is y equals to minus 3/4 x plus 6. Okay? Because for this case, you know the y-intercept. So straight away, you know C is equals to 6. But it's okay. Even if, let's say, oh, you miss out, you never think of it. You go and sub 8, 0 and get your C, or sub 0, 6 to get a C, you will still get the correct answer. So no worry. So no worry. Okay? Next. They ask us to find the area of AOB. AOB. So this one. Okay? This is automatically a right angle triangle. Why? Because y-axis and x-axis, this is definitely 90 degrees. So this is easy. Why? Because from here to here, from 0 to 8, you will know this is 8 units. Here from 0 to 6, you know this is 6 units. So to find the area, very straightforward. So you will straight away say area of triangle AOB is equals to half times 8 unit times 6 unit, which will give us 24 units squared. Done. Yes, 24. Okay, let's move on. Next, they ask me to find the length AB. Finding length by now to you should be easy. So length of AB. For easy reference, I'm going to write out the two coordinates here. My A is 0, 6 and my B is 8, 0. Okay, so length of AB, it will be x1 minus x2, so it's 0 minus 8 square plus 6 minus 0 square, and don't forget to square root. So, in the end, what do I get? I will get square root 64 plus 36, which is square root 100, which is 10 units. Yes. Yes, Pink? 10 units, Next, the length of OD. Okay, so this is slightly different, this one most of students don't know, but you see, the length of OD. So let us fill in the information first. My length AB, I have it, which is from here all the way to here. I have found that this is 10 units. Okay? Wait, I need to use the same diagram. From here to here, we have found that this is 10 units. Okay? Oh, I just noticed that actually you can use Pythagoras Theorem to find this. Anyway, you will still get the same thing. Okay, so the length of OD, where? Which is this one. They want you to find this. Question mark. So, this kind of question, you will use area of triangle. Okay, area of triangle. Just now we already found this area of this triangle, which is 24, correct? Now, if I turn my paper, referring to the same triangle, can I also use another set of base and height? I use my base, which is a 10 unit, then the red color one, which is the height, and which is the OD that they asked me to find. They want me to find, correct? So you will say that half times 10 units. Okay, I'm going to write the alphabet first. So half times AB times OD will give you the same area, which is 24. AB, we already found it. So it's half times 10 times OD is equals to 24. So OD is equals to 24 divided by 5. So OD is equals to 4.8 units. Done. What in red color? Okay? So always remember that area of triangle, we have 3 sets of base and height. So the first area of the triangle, we use this base and this height. Then the second triangle, I use half times 10 times the perpendicular height. And it will still be the same area because it's the same triangle. So you form the equation, half times the second base times the second height equals to the same area. Put in the AB, which we already found it over here. And then after that, half times 10 times OD equals to 24. So half times 10 is 5, right? So OD is 24 divided by 5, and that will give us 4.8 units. Next is trigo. A little bit of trigo in this coordinate geometry. Okay, same thing many students don't know. Those who do A Math should be able to do this because in A Math you learn all the four quadrants of the trigo. Okay, E Math students, those who don't take A Math will only learn the first 2 quadrants. Okay, so at the side here, I'm going to just state that A, S, T, C. So A means all trigo ratio are positive in the first quadrant. In the second quadrant, sine is positive, cosine and tangent is negative. So this is E Math, so I'm not going to talk more about the third and the fourth quadrant. So let's focus on the first and the second quadrant. They ask for cosine ABC. So let's go to our diagram and see what is ABC. Angle ABC. So they are talking about this angle over here. Maybe I use red color, it's not gonna see. This angle, they're referring to this angle reference. Okay, this angle reference. So if I'm going to draw it out, if I draw out this way, see how I draw? I draw out this triangle. This is the angle that they're talking about. Okay, this is B, this is O, this is A. This was 6 unit, this was 8 unit. Okay, and I'm going to label this as theta. Okay, so what you need to know is for E Math, you can just memorize. Cosine ABC. You see your ABC. Your ABC is obtuse. Okay, your ABC is obtuse. Obtuse means in the second quadrant. In the second quadrant, sine is positive, but my cosine is negative. So you will write cosine angle ABC is equals to negative cosine angle, the acute angle, which is the theta. Okay, in this case is ABO. ABO. You see that? It's the straight line. They want me to find angle ABC. I will say it is equals to negative. Why is it negative? Because in the obtuse second quadrant, cosine is negative. So put a minus there. Then you will say cosine the acute angle, which is the reference angle. And what is the reference angle? The reference angle is just next to it, which is angles on a straight line. So my ABO is a reference. So now looking at this, ABO is the angle, right? Angle reference. So that means this is my opposite. Opposite. This is my adjacent. Okay, I mean I talk about a bit of Picasso here. This is my adjacent and this is my hypotenuse. So we know that cosine is car A over H. Okay, A over H. So you will say, what if it's sine? Sine will be positive. That means if it's sine angle ABC is equals to positive sine angle ABO. Okay? Because sine in second quadrant is positive. So in over here, I will say is equals to minus cosine ABO is A over H. So it will be 8 over hypotenuse. So I forgot to write, this one is 10 units. Just now AB we already find So it will be minus 8 over 10, which is negative 4 over 5. And we're done. Okay? Someone get blocked. Okay. You all don't disturb lah. You know my moderator, she work whole day. You know, since 9 AM she work already, and she's still helping me to do the moderation. Okay, you all don't piss her off. Try to disturb and disrupt us on teaching, then she will just block you. Too bad. Okay, so negative 4 over 5. Okay, let me do some optional additional question. So in case it come out like just now the student asked what if it's sine, right? What if it's sine? So if they ask for sine angle ABC, again ABC is the obtuse. So it means it is equals to sine angle ABO. Because in second quadrant sine is positive, so I do not need to put minus there. So that means it's equals to O over H. So it's 6 over 10. So it's 6 over 10, which is 3/5. And you're done. Now, next, you must be fair, right? I do cosine, sine, I also need to do tangent. Okay, if it's tangent angle ABC, same thing, ABC is obtuse. And in the second quadrant, only sine is positive. Tangent and cosine is negative. So you will write is equals to minus tangent angle ABO. So which is negative O over A. O over A which is, O over A is 6 over 8. So it's 6 over 8 which is equals to negative 3/4. So do you notice? Do you take note that cosine is negative ratio, tangent is negative ratio, and sine is positive ratio? Okay, so for EMath students, for this particular segment, you just need to memorize this. Okay, of course, those who take A Math, please, you need to know more than just this. You cannot just purely memorize this part because you need to know all 4 quadrants, and trigo is a huge topic in A Math. Okay, for E Math, about the 4 quadrants, you only need to know this. Just purely memorize. Sine is positive, cosine and tangent will be negative. Understand? Okay, let's move on. Okay, okay, we are done with coordinate geometry. We are going to do further trigo. Okay, we're going to do further trigo. Slanted. Okay, so who needs help for further trigo over here? Say hello to me if you need help. As in like, are you waiting for this segment whereby I'm going to teach further trigo? Are you waiting for this? Do you need help for this? Again, if no one responds, means that no one needs help for further trigo. If no one needs help for further trigo, means I also can off work early, right? Okay, Jade needs help. Okay. Okay, good. Okay, so yeah, students want to know further trigo. Let's go on. So further trigo will involve sine rule, cosine rule, half AB sine C, and then you have the bearing, okay, and then angle of elevation, depression, you know, shortest distance. It's always the same thing. Further trigo is one topic whereby it's the weightage of the question is quite heavy also because there's many parts. And I can say that the questions are always similar. It's always sine rule, cosine rule, you know, the same thing, bearing, blah, blah, blah. Okay? Okay, let's move on. Let's make sure that all the information are transferred. AB is 18, okay, acknowledge. BC, 7.5, acknowledge. 16.5, 30. And they tell us that BCD is a straight line. So BCD straight line is just trying to tell you that these two angles add up together to be 180, that's all. Okay, acknowledge. Now they ask you to show that a triangle ABD is a right angle triangle. Every time they ask you to prove right angle triangle, it is the popular person called Pythagoras. You need to use his theorem to prove that whether a triangle is right angle. Okay, a lot of students know that it's always linked to Pythagoras theorem, but they always cannot get full marks for that part. Why? Because of the presentation. So take note of how I present this kind of question. You will take the two shorter length. So this triangle, my two shorter length is of course 18 and BD, which is the two length that's guarding the 90 degrees. So they are assuming that this angle is 90. You are supposed to prove whether is it 90. So you will write out AB square plus BD square. So it will be 18 square plus BD will be 7.5 plus 16.5 square, and that will give us 900, which is equals to, see how I present 900, you will say it is equals to 30 square, which is equals to the third side, AD square. You see how I show? You will take the two shorter one, square them first, put it into, it's 900, so it's equals to 30 square, so it's equals to AD square. So this is the correct presentation. Then after that, most importantly is you must mention the person name. Okay, it's his theorem, give him some credit. So you will say, therefore, by converse, okay, please use the word converse of Pythagoras theorem, triangle ABD is right angle. Done. Okay, so this is how you present. Understand? Please make sure you present this way and get the marks, because everyone know how to know. They know that you want to use Pythagoras theorem, this person theorem, but they don't know how to present it. Okay, like what they like to present is, they end up saying that 30 square equals to 30 square, which is like, it's very not logical. Understand? Okay, next move on. So now you see, I already proved it's 90 degree, right? Please remember to mark out that this is 90 so that it will help you to do the behind question. So let's move on. This is the part whereby see whether you all learn my just now the sine, cosine, tangent thing about the trigo. So they say, giving your answer as a fraction, find the exact value of sine ADB. So let's go to the diagram. ADB. This is fine. Why? Because ADB, this is obtuse. Okay. So if they say ADB, you look at the big right angle triangle, look at this one. So you will look at this one. So I will draw here so that it's easier for you to refer. So of course I will draw out this shape. A, D, B. This is 18, this is 90, and we know that this is the one that we are talking about. I put it Peter. DD I have, which just now we already found it, which is 24. Okay, so this is what we have. Okay, so just showing you this triangle, I just draw out here. And you see that I do not did not draw this line AC. I did not write because they want this angle. They are looking at the big triangle. Big triangle. Okay. For me, I always like to draw out so that it's easier for me to refer. So now look at this. They ask for find for sine ADB. So it means sine angle ADB is equals to this. Is my angle reference. So this side will be my opposite. This side will be my adjacent. And the longest side is always the hypotenuse. So sine is Hua Ka So. So S-O-H. S-O means it's opposite. Means it's 18 over 30. And take note, a lot of students go and find the angle. They are asking you what is sine angle ADB. They are not asking you to find the angle. So you do not need to sine inverse. So you just need to reduce this to the lowest term. So it's just 3 feet. Done. Okay. Now over here. They ask for ACD. Where is my C? ACD is here. Okay. Okay, then I will have to draw another one. Okay, see here. Now they ask for cosine ACD. So where is my cosine ACD? Let's take a look. They say angle ACD. Now they're referring to this. And do you notice that this is obtuse? So I'm going to draw another triangle. This time round, I don't need to draw this one. I now only need to draw the smaller triangle with a line, straight line. So you will draw a smaller triangle. Extend because I want to write this is C. Sorry, this is D. This is D. This is C. This is B with this one 90 degree. This is A. This is 18. This one is 7.5. Okay, so this time round, they want ACD. ACD is this big one. And remember I said cosine, as long as it's obtuse, it is negative. So all you need to do is, okay, this one is my angle reference. Okay, I never use theta because theta is already used here. I don't want to use, if I write theta here, I'm trying to say that they are the same angle, but they are different. So I use alpha here. So I will say cosine angle ACD equals to negative cosine. This side ACD is here, right? So the other side is ACB. Angle ACB. So again, you have to know where is the opposite, adjacent, and hypotenuse. So this is your angle reference. Arrow. This is my opposite. Opposite. 90 degree, adjacent, and then hypotenuse. So I'm doing cosine, which is ka. For ka, so is ka. A over H. So it will be A, which is 7.5. Remember to put a negative. 7.5 over the H. And what is my AC? Let me see whether just now did I find my AC. Wait, I don't have my AC yet. Okay. So now you see, I need my AC, right? But I don't have my AC, right? It's okay because this is a right angle triangle. I have two sides. I can easily use Pythagoras Theorem to find my AC. So I'm going to do here. So my AC square is equals to AB square plus 7.5. These are purpose. Which is 18 square plus 7.5 square. So therefore my AC is square root 18 square plus 7.5 square. And that will give us 19.5. So 19.5 units, which over here means is 19.5. Press the calculator, of course, and you will get negative 5 over 13. And you're done. You make sure the minus is obvious. Okay? So this is how you do this kind of question. If I was using another triangle other than alpha and delta, should I use beta? If I was using another triangle other than alpha and delta, yes, can. That will be the third. Usually my sequence, I use beta first, then alpha. After, if these two also use already, then I use beta. Okay, if all three also use already, then I also don't know what to use already. But usually, won't be so many unknown angle lah. Okay, so let's move on. Ta-da! This is a typical question that they always ask. So just now, those questions I wanted to cover the obtuse, trigo obtuse, okay, which a lot of students always don't understand. So now we're going to do further trigo. Okay, further trigo, sine rule, cosine rule, most students are able to handle. But every time they tell you, oh, a tower, then what is the equators of angle of elevation, then what's the shortest distance, then students don't know how to do the part already. Okay, so how are we going to do that? We will do this today. I think I have 2 questions doing this kind. Again, let's read the question and make sure that the information is transferred to the diagram. Okay, in the diagram, ABD represent a horizontal triangular field. C is a point on BD such that BC to CD is 2 to 1, 2 unit. So they know that this is 2 unit and this is 1 unit. I can measure this. This is 3 units is 96. So I'm going to write here 3 unit 96, 1 unit 24. Sorry, it's 32. 32, and then 2 unit will be 64. So with this, I can already put here, this is 64 and this is 32. Okay, let's move on. Now they tell me AE represent AE is this one, represent a flagpole which is 25 meter high. Okay, they already put there. Okay, so this is a pole. This is a pole. BD is 96. Okay. ABC is 38. Okay. And then ACD is 130. Okay. So all the information are now in the diagram. We can move on to do the question. First, they ask to find the length AC. Okay. To find the length AC, I look at the triangle around it. I have 2 non-right angle triangle, either ABC or ACD. So you have to see what triangle has enough information for you to do. Take note that this is 130, right? You should know that this is 50 degrees first. So put it in. Okay? You know this 50 degrees. And this is a triangle. This angle plus this angle add up is 180. Agree? So you can find this angle as well. So just fill in whatever you can find first, because you will be able to analyze and see which rule you are going to use. So now in this triangle ABC, obviously I will use ABC to find my AC, because my ABC has so many information. I have all the 3 angles as well as one side. If you look at ACD, I only have 130 and 32. Definitely not enough information for me to use sine rule or cosine rule. So look at this triangle and let's see which one we should use. We are supposed to use, we are finding length AC. So AC over opposite 38 degree, and I have the length 64 and 92 degrees. So it means that I can just use the easier one, which is the sine rule. Sine rule. So the length AC is here. So let's put in the known one, 64 and the 92. So means I will write 64 over sine 92 degree is equals to AC, which is the one they asked me to find, over sine AC is the one that unify, opposite is 38 degree. Cross multiply. So my AC is equals to 64 sine 38 degree over sine 92 degree. And that will give you 39.426. Round it off to 3SF, 39.4 meter. 3SF. So this one we found is using sine rule. And don't forget to always update the diagram. So 39.426, put it here. 39.426. Please don't put 39.4 in the diagram. You must always use the long number to do your calculation. So always write the long number in the diagram. Okay? Okay, let's move on. Next is they ask me to find AD. Let's see, where is AD? AD is here. Okay? Okay, not so difficult. Why? Because now since I already found my AC, look at the triangle ACD. Now I have three information. I have the length AC, I have the length CD, I have 130 as well. The only bad news is I have to use cosine rule. Okay, I have to use cosine rule. So let's see. Okay, I'm just going to draw this triangle here so it's easier for you to refer. So my diagram might not be exactly the same as the in front, just for estimation only. So this was the 130 degree A, C and D. So this was 39.426, this was 32. So we are supposed to find this unknown. Okay, so I'm going to use cosine rule. So my angle given is 130. So the opposite side must be on the left hand side. So we will know that AD square is equals to AC square plus CD square minus 2AC and CD cosine 130 degree. Okay, this is the formula. Then let's put in the numbers. So it will be 39.426 square plus 32 square minus 239.426 32 cosine 130 degree AD. Then I'm going to put the square root. So this one, press calculator and make sure that you're in the degree mode. Why? Because 130 is degree and not radian. So press the calculator, you get 64.80. Round it off the 3SF, 64.8 meter 3SF. Okay. Okay, next. Don't forget to update the diagram. I found my AD, right? So I need to update my diagram. So my diagram AD here, this is 64.8099. Okay, 64.8099. Okay, now let's move on. They ask, depression, angle of depression. Angle of depression. So let me talk about elevation and depression. Okay, just I will write red color. I write red color here is because it's information only. So let's say I have a building. So this is the floor. Okay. So let's say you are standing right here. So this is person A. So now you are here. Another person. This is person B. Okay, so you need to know about this elevation and depression thing. So I'm going to draw a line. Okay, draw a line. So when we talk about angle of depression, okay, it means that you are looking downwards. It is eye level and then looking downwards. So my angle, my A, person A, I draw a horizontal line. Depression is looking downwards. So this is angle of depression. Okay, this is angle of depression. Okay, this person B is looking upwards. He is looking at A. So if he's looking upwards, that's called angle of elevation. So it's horizontal, then move up. So it means this is angle of elevation. Okay, and you need to know that this so-called eye level and the floor, it is parallel line. So in other words, you must know that whenever we talk about angle of depression and angle of elevation, they are the same. So angle of depression is the same as angle of elevation. Understand? Okay. Common mistake is students say the angle D is here. Then it's wrong. Okay. So take note, angle D is not there. Yes. A lot of people always thought that it's the one that I wrote. But this is wrong. Okay, this is wrong. This is the correct angle of depression. Understand? Okay, so after understanding this, let's go back to the question. Now they ask you to find angle of depression of D from E. So over here, they already have the diagram here. You are supposed to angle depression of D from E. So you're looking from here. But take note, because this is 3D. So if you look at it, it looks like, hey, it's not a right angle triangle. But it is, You can see that they actually put a 90 degree here and show it to you. But you need to know that this is actually 90 degree. So if I'm going to draw out the triangle, I'm going to draw flat 2D. So it's actually E, A, and D. This is 64.8099. This is 25. Okay? If D is inside, then it's not equal to E. If D is inside, then it's not equal to E. No, the thing is, D is definitely not inside. D is definitely not inside, because depression is eye level looking downwards. So this is depression. Depression and elevation is definitely the same, as long as we are talking about the same triangle. Understand? Okay, so they say angle of depression of D from E. Means that it's like, this is how you take it. If your person is standing here, eye level, look down. So they are talking about this angle of depression. Okay? And this angle of depression, Z, they want this. So in this question, I'm going to put this as theta. So in this case, although they are asking for angle of depression, but I can use a triangle and find the angle EDA. It's the same angle. Okay, why is it same? Is already explained to you. Angle D and angle E is the same. So, to find the angle of depression, it means that I will use this triangle. So I redraw here. Okay, theta opposite. See, this is my opposite. This is my adjacent. So O and A is 12. So you will say, okay, tangent theta is equals to 25 over 64.8099. So to find the angle of depression or the angle of elevation is the same thing. So it's tangent inverse 25 over 64.8099. And that will give us 21.0937. So drawing off the 3SF, I get 21.1 degree. 1 dp. Okay? So do you get a better understanding what is angle of elevation, angle of depression? So we are not done with this question yet, not done, because the next common question that they would like to ask is always the shortest distance. So let's move on. Why is it tangent inverse -1 and not minus? This is the language of tangent inverse. So I don't understand why you ask me why is it not minus tangent. It's always, to find the angle, it's always tangent inverse the trigo ratio. Okay. Next, they ask to find the shortest distance from A to BD. This is not easy, 3 marks. But you should already know when you're doing a simple trigo, why is it that it's tangent inverse -1? Okay, because when you learn about trigo Picasso and you want to find the angle, you should use inverse. Sine inverse, the trigo ratio, tangent inverse, or cosine inverse. Okay, so that's the language of inverse. Okay, so it's not minus tangent. Don't get confused with the obtuse thing. That obtuse thing is a negative ratio. This is while trying to find the angle. Okay, so you don't get yourself confused. Okay, let's move on. Where's my diagram here? They ask to find the shortest distance from A to BD. A to BD. Always remember, okay, whenever they say shortest distance, it means it's perpendicular distance. This is how I always tell my students. Okay, imagine you are here, you're walking from B to D. You're walking from B to D. You are supposed to go to A. Okay, what is the shortest distance, where is the place whereby it's the shortest distance to walk to A. Okay, of course I will come here and after I walk here, right? This is the shortest distance. You understand? Shortcut. So it's perpendicularly over. Understand? So it means they want this. You can mark this as X. It doesn't matter. As long as there's no other X. So the perpendicular, or rather call the shortest distance in this case is actually AX. Understand? Please remember, they always say shortest distance is just perpendicular distance. So it's actually AX. So there's two ways to find AX. Okay? You can use Picasso again, or you can use the area of the triangle. So not all the time you can use area of the triangle. Not all the time you can use Picasso. So you must see whether you have enough information to use Picasso. So now let's take a look at this one. I can see that I can have AXC. You see AXC? You must have the angle, then you can find. I have a 50 degree. So it means I can use Picasso to find the AX. So after I draw this already, I'm going to draw the triangle over here. This is X, this is A, this is C, this is 50 degree. This is the unknown you are supposed to find. Okay, and I have the length AC, which is 39.426. Okay, Picasso to find unknown length with angle, as long as we have two information. So I have the angle reference, which is 50 degree, and then I have the length 39.426. So next is you have to decide, do I use sine, cosine, or tangent? 50 is your angle reference. So opposite is here. OPP is here. 90 degree, here is adjacent. And this is hypotenuse. I'm supposed to find my opposite. So of course I must use O. I have my hypotenuse. So I have to use H. O and H. So it's sine. Okay. So I have to form the equation with my sine. So I will say sine 50 degree is equals to O, which is AX, over hypotenuse, which is 39.426. Okay, cross multiply. AX is equals to 39.426 multiplied by sine 50 degree. And with this, you will know that, okay, let me press the calculator. So 39.426 multiplied by sine 50. That will give us 30.202. Round it off to 3SF. So it's 30.2 meter. 3SF. So you see, we are done. So again, go back to your diagram and update. So now we have found this. You want to put red color also can. I took FBB math, no bridging course this year. Then after that, AX here. So is 30, what is SBB math? 30 subject-based bending math, no bridging course this year. So you're taking express math. 30.202. Always write the long one. So I have my shortest distance already resolved. NA to express math. Wow. Okay, then you really need to put in a lot of effort, because there is already a gap definitely from Sec 2 normal acad and Sec 2 express. So you straight away jump to Sec 3 express, the gap is even bigger. Okay, so my suggestion is go and study Sec 2 express topic to close up the gap for the Sec 2 first. Understand? Because a lot of things are covered under the Sec 2 which are not covered in Sec 2 normal acad. Cover that gap, then you will feel better and do better in Sec 3 express. Okay, that's all I can say. Okay, what am I going to do? Okay, next question. Now, this one, another one, they ask, what is the greatest angle of elevation of the top of the flagpole when viewed from a point along the BD? Every time they ask this question, let's take a look at the diagram. Our pole is here. Okay, this is our pole. Okay, of course, this one is not drawn and show it to you clearly. So I'm going to draw one additional line. Okay. For those who can visualize, good for you. Okay, but I definitely will draw it again. So if you look at this, okay, they are saying that what is the greatest angle of elevation? So let me explain to you about greatest angle of elevation. Okay, you imagine the pole, or rather they say the building is in front of you. Okay, the building is in front of you. Angle of elevation, we have mentioned that is looking upwards. Looking upwards. So when is it the greatest angle of elevation? Is it when you are the furthest from the building, or is it that when you are nearest to the building? When you go nearest to the building, your head has to rise higher, right? In order to look at the top of the building. Okay? When you are standing further apart, your head actually is tilted down. So to have the greatest angle of elevation, greatest angle of elevation means that you need to stand as near to the building, which is the shortest distance. Understand? Shortest distance. Yes. And so that's why our AX, which we found in this part, is helpful. But sometimes the question, they do not have this part. They straight away ask you to find the greatest angle of elevation. So you must know that you need to find the shortest distance first before you can do this question. You understand? So this question is very kind to actually break it up for you. So now with that, I will draw the diagram. Because this diagram over here, it is not drawn the flat. I'm going to draw the 2D version. Okay? So it means that it looks like that. A is here, X is here, and this is the top of the building, which is E. Sorry, top of the flagpole is E. And we know, of course, the so-called the floor and the pole, this is definitely 90 degrees. AX, we have found it previously, which is 30.202. AE is the flagpole, which is 25 meters. Okay, so we have agreed that AX is the shortest distance, and this is your pole. This is your pole. So they want to find this angle. Just now I got used theta already, right? Okay, I'm going to use alpha. So this is the angle of elevation that we want. Largest, greatest, because AX is the shortest distance. Understand? So this is the one whereby you look at, you just visualize that you are looking from this point to this side. From here to here, you will see this right angle triangle. So of course, this is not easy to visualize. So I always draw out a right angle triangle, and I will put EAX. Then I put in the information. Then it's easier for us to visualize. So again, the greatest angle of elevation is just using tangent rule. Not tangent rule, tangent. So this is my opposite, and this is my adjacent. So it means that I have my opposite, I have my adjacent. I will use tangent. So you will say, okay, tangent alpha is equals to 25 over 30.202. So my alpha, which is the angle of elevation, is tangent inverse 25 over 30.202. And that will give us, where is it? 39.616, and round it off to 1 dp because this is angle 39.6 degree. Done. 1 dp. Okay, so this is how you find greatest angle of elevation. Whenever they tell you to look up to some pole or look up to the building, always find the shortest distance. Okay, easy. Okay, we are done with this question. Let's see how many questions. Okay, I'm left with 2 more questions to do. Okay, so I'll go very fast already because basically behind, other than bearing, the rest I already cover sine rule, cosine rule, whatsoever in front. So some parts I will go very fast. Only the bearing I will take a little bit longer because I haven't covered bearing. Okay, let's go. Now we're going to do question 3. Okay, before I continue, same thing. For those who haven't followed me, please follow me. For those who haven't gone to my Telegram channel, please go and subscribe to my Telegram channel. For those who haven't subscribed to my YouTube channel, please subscribe to my YouTube channel. Please share to your friends so that they can learn together and also help me to get more YouTube channel subscribers. Thank you. Okay, or if you want to recommend me students, you also can recommend me students. Okay, for my full-time students lah, because I teach full-time tuition. That's my main job, right? Okay, let's continue. ABC da 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 da. Okay, see bearing. Again, make sure that we have all the information to the diagram. AC 88.2, BC equals to 57, bearing of B from A is 40 degrees. Okay, so now let's take a look at this one. All the information are in the diagram already. So now they ask to calculate angle BAC. BAC. So you're supposed to find this. I'm going to label this as theta. Okay, let's see what information we have. Okay, this definitely is sine rule. 57 over sine theta, okay, equals to 88.2 over sine 85.4. Sine rule, So it will be 57 over sine theta is equals to, hello, Isabella. Thanks for the rose. 57 over sine theta equals to 88.2 over sine 85.4 degrees. Okay, so using sine rule, cross multiply, so I have my sine theta is equals to 57 sine 85.4 degree divided by 88.2. So then after that, we will do theta sine inverse. So this one, put it inside, this whole thing. Then after that, it will be equals to 40.103. Round it off to 1 dp, 40.1 degree. 1 dp. So again, update the diagram. So this one is 40.103 degree. Okay, this one later I'm going to adjust a bit. Got smaller. 40.103. Okay. Next, bearing. Okay, they ask to find the bearing of C from A. Okay, kids, this is how you get the so-called the direction. They say from A, so that means you will go to your A. You're going to put the north pole, which they already draw it for you, so you don't have to draw. But if it's not drawn for you, you got to draw the north pole. So it's drawn already. Next, they say C. So then after that, you go and look for the line AC. AC is here, correct? So what you need to do is clockwise. What they want is from here to here. This is the angle that they want. This is called the bearing of C from A. At the A, put the north pole, go clockwise, look at the line AC, that will be the angle that they want. So in this case, it's very straightforward. It's just 40 plus 40.103. Okay, so you will say bearing. So maybe you find angle first. So you will say angle NAC is equals to 40 degree plus 40.103 degree. So you get 80.103 degree. Okay. Bearing, take note, it must be 3 digit. Okay. So if you don't have 3 digit, for this case 80 is 2 digit, you got to put 0 in front. So you will say, therefore, bearing of C from A equals to 080.1. So some students say, must be 3 digit. Then I need to put the 0.1 or not. Take note, angle is still round off to 1 dp. So whether is it 3 digit or 2 digit, you still have to put the point something for 1 dp. Okay? So it's 080.1 degree, and that's the answer. 1 dp. Okay? Okay, let's move on. Calculate the area of the field. So, let's take a look at the diagram. And we shall see whether we have enough information to do half AB sine C. Because for area of non-right angle triangle, you use half AB sine C. Although bad news looks like it doesn't have enough information, but I can find. Because if you look at the triangle, I have 85.4, I have 40.103. I can easily find this angle over here. So what you need to do is 180 minus 85.4 minus 40.103, we will get 54.497 degree. Okay? And you see this. Half AB sine C means half AB sine C. The angle must take the two lengths that is like included. So I will use 57, 82.2 as well as this angle over here. So I will say area of the field is half AB sine C, which we will use. Can we do vector? I'm confused even after my chair. I already did vectors few lessons before already. Okay, area of the field. So it will be half 57, 88.2 and sine 54.497 degree. And you get 2046.365. Round it off to 3SF. (2050) km squared. 3SF. Okay. See the next question. Find the shortest distance from B to line AC. So in this question, I'm going to use the half times base times height. Just now previously, I used the Tuakaso to go and find, right? But this time around, I'm going to use the triangle one to show you. They want B to line AC. So let's go and see B to line AC. So what they want is this. They want to find this. So again, I'm going to label this. Do I have X? Okay, I label this as X. Again, I want to find BX. So although I can use this. Let me see, can I use this? I can use this side. Okay, I can use BXC. Okay, because I have this angle I can use O and H. I can use sine to find the height. But I want to use the area to show it to you. So, I will say half times base, which is AC, AC times BX. AC times BX is equals to the same area, which I'm going to equals to 2046.365. So this is half times 88.2 multiplied by the so-called height, which is the BX, is equals to 2046.365. So my height is equals to 2046.365 divided by half times 88.2. Press calculator, you get 46.4028. Round off to 3SF, 46.4 km. Okay, so this is 3SF. See, I use area of triangle because remember I say area of triangle will not change. They have 3 sets of base and height. So in this case, of course, I didn't use the first base and height to find the area of triangle. I used half AB sine C to find the triangle, area of the triangle. Then I go and form half times base times height for the same area, and I form an equation with the unknown, which is the height, which is the shortest distance, and that's how I find. Okay, again, let's go back to the diagram and put in the information. 46.4028. So this will be 46.4028. Okay, let's see whether they need more thing or not. Oh, don't have. That's all they want. Okay, so for this question, same thing. Again, I talked a little bit about bearing, which is something new compared to the previous question. Okay, and I use a slightly different method. Although just now the in front part, I think the coordinate geometry, I did area of triangle thing as well. But this one is further trigger, you also do the same thing. It's always the same concept for the shortest distance. Okay. Yeah, we are at the last question for the night. Question 4. So again, it's quite similar to just now in front. It's just different diagram. That's why I tell you, it is always asking the same thing over and over again, just changing the diagram and maybe adjust a little bit about how they ask, but it's always asking the same thing. Okay, So let's continue. Again, read the question and make sure you get all the information into the diagram. Okay, 4 points A, B, C, D, okay, on a level ground, and then where blah blah blah. Okay, when they say on a level ground, it's trying to tell you this thing that you see is exactly flat on the floor. It's exactly flat on the floor, understand? D is due west of C. D is due west of C. And you see that over here they put the compass here, north is pointing upwards. So you can already put, just now this one can extend, so you can actually put this one, this is north. Okay? Follow the direction that they give you. They say D is due west. West means that they are trying to tell you this is 90 degrees. Understand? Okay, let's move on. Given that CD is 120, 115, 55, 40, 33, all information given, written already. Next, they want to find AB. Where's my AB here? Okay, so how am I going to find AB? Again, easy. I already have 40 and 33. So we're going to find this angle here, which is 107. So I go very fast because I already went through quite a few just now. So I will do 55 over sine 40 equals to AB over sine 33 degree. Cross multiply, AB is equals to 55 sine 33 degree over sine 40 degree equals to 46.6019. Round it off to 3SF. (46.6 meter). 3SF. Fill in the blank, my AB. So this is 46.6019. Okay? Let's move on. Now they want me to find angle BDC. BDC. So that means they want this angle. Haven't used theta, right? Okay, I'll mark it as theta. Okay, so now the bad news is I have to use cosine rule. Because 3 sides is given, not even one angle is given. When not even one angle is given, is cosine rule. Because we cannot use sine rule. Sine rule, you must minimum have one angle, right? So we're going to form the equation. So it will be 115 square equals to 55 square plus 120 square minus 255 120 cosine BDC. Okay, this is the cosine rule. So your task is to make cosine BDC the subject. Okay, like I mentioned before last time, see this. This is one term. So this minus something cosine angle BDC, the whole thing will go to the left hand side. Okay? And then this 115 square I will bring to this side, so it becomes minus. So now I will have 2155, not 155, 55. 255 120 cosine BDC is equals to 55 square plus 120 square minus 115 square. Cosine BDC is equals to 55 square plus 120 square minus 115 square divided by 255 and 120. Okay? This one, when you press the whole calculator, you get 7 over 22. So cosine BDC is 7 over 22. So to find angle BDC, cosine inverse 7 over 22. And that will give you 71.4469 degree. So round it off to 1 dp, 71.4 degree. 1 dp. Done. So you have to be very careful on this cosine rule. Why? Because a lot of students, many students, they go and combine this as a one number. This part, they go and do 55 square plus 120 square minus 2 times 55 times 120. Then they put as one number. Then they say this one cosine angle BDC, but it's not correct. It's not correct. You must know that this 2 times 55 times 120, it only belongs to the cosine angle BDC. So it's this square plus this square minus this whole thing. So this whole thing is together. So when you want to shift them, you shift them together. That's why I shift this over to the left hand side. Negative this, bring to the left hand side, become positive. Okay? Then the 55 square plus 120 square remain here. This 115 square I bring over the other side, it becomes minus 115 square. Then this time now, in front now, I can bring over. When you bring over, you see it's a divide. Okay, it is a divide because here is multiply. Bring it over, divide, press calculator, cosine inverse, and this is your angle. Okay, so let's update our diagram. This is BDC 71. So we will update BDC here is 71 point. What is it? 71.4469 degree. Okay. The bearing of B from C. The bearing of B from C, B from C. C, I already put the North Pole. Let's go and find the length BC. Oh, the length BC is here. So actually, they want the bearing. But take note, bearing is clockwise. So that means from here, clockwise to the line BC. So this is the bearing that they want, Okay, so how am I going to find this? Again, let's see. So I'm going to find this angle over here first. Can I find this angle? Actually, can. Why? Because look at the triangle BDC. You have 115, you have 55, you have 120, and already just found one angle. So to find another angle easily, you can just use the sine rule. So we're going to use sine rule. So we will say 55 over sine. This time round I have to use alpha already. So sine alpha is equals to 115 over sine 71.4469 degree. So I will have sine alpha is equals to 55 sine 71.4469 degree divided by 115. Okay, and the alpha will be sine inverse, this one, put it inside, and you will get 26.962 degree. Okay, but take note, 26.962 is this mini angle here, is here, so it's 26.962 degree. But I want this bearing over here. Do you agree? Okay. Yes, well done. Because from here to here, because this is 90, right? Remember? So this is actually 90 degree. This is 360 minus 90, so it's 270. So therefore, you will say bearing of B from C is equals to 270 degree plus the small one, which is 26.962, and you will get 296.962. And remember, bearing is 3 digit. This is already 3 digit. Don't have to put 0 in front. Round off to 1 dp. Because this is 6, round up. Oh, you max again, so I have to round up here. So it's 297. You still have to put 0.0 because you want to show that it is 1 dp. 0.0 degree. So 1 dp. Done. Okay, so I'm done with this part, bearing. Okay, let's move on to the last part. Again, they like to ask about a tower, blah blah blah. Okay, so this one stands at B. Let's go and look at the diagram. So B. Okay, this time they never draw out for you. Okay. Then they say that the angle of elevation of the top of the tower is from D is 70 degrees. From D. Okay. So in this case, I will have to draw out the diagram in order to visualize. So you see, they say they want, I'm going to draw B and D. So you see how I transform. BD is the floor, right? BD. So it's 55. They say this, they say top. So I shall use this as T. Okay. The tower stands at B. Angle of elevation of the top of the tower from D is 70. So it means draw up. Yeah. Okay. It should reach. This is 70 degrees. And this is 90 degrees. So you want to find the height, which is the BT, question mark. So again, Picasso, this is my opposite, this is my adjacent. So this time round, I have my, I need to find opposite, I have adjacent, and I have angle, so I need to use tangent, Hua. So you will form the equation, tangent 70 degrees is equals to TB over 55. So my TB okay, will be equals to 55 tangent 70 degrees, which will give us 151.111. And take note, this is asking for 2 decimal places. It is not asking for 3SF. So it's round off 151.11. Okay, so take note, this is 2 dp because they requested meter. And we are done with this part. Next, then you see they ask the same thing. The greatest possible angle of elevation of the top of the tower from a point of BC. So this time round, let's take a look at the diagram. Come back to here. Okay, I'm going to draw. Let's say this is the. Again, they're asking you when you're walking around this CD, okay, what's the greatest of angle of elevation? Again, they're asking for the shortest distance. And again, I'm going to mark this as X. Okay, but of course, it looks like this one is exactly straight, but it is not. It is just that at this point of time, when you're looking at top view, when you're looking at top view, you only see this straight line. But if I'm going to draw another view, which is from this view, okay, this direction, you will draw this. This is how you're supposed to draw. So we will draw the here. No, I should draw another one first. I need to find my shortest distance first. This is a question whereby they did not break up shortest distance and the greatest of angle of elevation. So you need to go and find the shortest distance first. Okay. So you will come back to here. I will use the Picasso to do it. Look at here. I have this triangle over here. BDX. So I will use BDX. This is the unknown. 55 I have. Angle I also have, which is 71.4469. So with this, you'll be able to find BX, opposite, and hypotenuse. So it's sine. So we will use sine. So you will say sine 71.4469 degrees is equals to BX over 55. So my BX is equals to 55 sine 71.4469 degrees. So you will get 52.1416. Okay. But we are not done yet. We are not done yet. This is only the shortest distance, which is our 52.1416. Okay. I need to find what's my greatest angle of elevation. So I need to draw another triangle. Okay. I'm not going to draw here. So we're going to confuse you. I will draw it at the bottom. So it means that I will draw this way. B, this one is a building. So BT I just now already found already, which is 151.111. This is definitely 90. BX is what we just found, 52.1416. So it's 52.1416. And we are supposed to find this. Okay, I think I already used theta and alpha. So now I'm going to use beta here. Okay, so to find this, easy again is tangent. Okay, this is opposite. And this is adjacent, hypotenuse. Okay. So we will say, okay, tangent beta is equals to 151.111 over 52.1416. So the angle beta is tangent inverse. This one, throw it inside. You will get 70.962. Round it off to 1 dp, 71.0 degree. 1 dp. Done. Yes, trigo is fun. I also love trigo. Okay, although it is this, okay, further trigo is confusing because there's a lot of so-called right angle triangle that you need to use, but it is not able to seen by the flat view. Okay, so every time I just draw it separately. Okay, so it's easier for you to visualize. Okay, so we are done with the last question for the day. Okay,